Hello everyone, welcome to Gate Wallah English YouTube channel. I hope everyone is doing great. So till last lecture we have covered precipitation. Okay. Good evening everyone. First everyone kindly comment that I'm fully visible and audible to you all. Then we'll begin our lecture. So we'll proceed with precipitation topic. Okay. Tell everyone that am I fully audible and visible to you all? Good evening Sushil. Good evening dear. How you all are? Kindly comment once. Then we'll proceed with our lecture. Okay. Yesterday we have covered some topics, few topics of precipitation. Today we are going to proceed further with estimation of missing data and optimum number of rain gauges that I have already discussed yesterday. Wait a second. Okay, no issues. So till last class we have seen in the last class we have seen types of precipitation. I hope you remember all the types of precipitation. We have discussed what? Firstly, we have discussed convective precipitation. I hope you remember. Everyone kindly comment that convective precipitation was caused because of which phenomenon? Pressure difference, temperature difference, or orographic barrier, or due to meeting of hot and cold air? Can you comment once? Convective precipitation is caused because of what? Can you tell me? Yes, perfect. Perfect. It is caused because of temperature difference. This was the first one. Perfect. Great. And second one was my orographic precipitation. This was caused when moisture laden winds were forced to move up through a mountain barrier. This was orographic. Then the third one was our cyclonic one, in which because of pressure difference, okay, in which because of pressure difference we saw that cyclone is being developed. Okay, wind is coming to a low pressure area and moving in circular fashion. Okay, that we have discussed in cyclonic. And last was your frontal, which you can see on this screen as well, in which you have seen that warm and cold air meets at the interface. See, at the interface you can see clouds have formed. Okay, here at the interface precipitation has happened. Okay, this we have discussed yesterday. Then we went on to discuss all the forms of precipitation. Okay, first we have discussed the rainfall. Drop size also we have discussed, like drop size is somewhere ranging between 0.5 to 6 mm. Okay, no drop size which is having a size more than 6 mm is stable. It will ultimately break into small pieces. This we have discussed. This was the classification based on intensity. If intensity is less than 2.5 mm per hour, then it is light rainfall. If it is ranging between 2.5 to 7.5 mm, it is moderate rainfall. If it is greater than 7.5 mm per hour, then it is heavy rainfall. This classification we have discussed. I hope you remember it. Yes or no? Perfect. Then we discuss snow. Snow is light and it is opaque in nature. It is pure white. It is very light. Okay, average density is varying from 0.1 gram per cc to, see, it is somewhere you can say 10 times less than that of water. Yes or no? Then we have discussed sleet. Sleet is what? Mixture of snow and rain. And this snow is translucent, or simply you can say transparent, through which you can see. And in this one, along with rain, you will see that small snow pellets of size less than 5 mm are falling. Okay, so this is sleet, mixture of snow and rain. Okay, what is hail? Hail storm, you can see these are bigger pellets. Okay, these are very destructive in nature, and it will ruin the crops. Okay, if they will fall in the farm fields, then obviously it will destroy the crops. This is very unfavorable, or you can say disastrous for farmers. Okay, so it should not be there. This is undesirable. Then we have very small drops, that is drizzle. Very small drops, minute drops, whose drop size is even less than 0.5 mm. Intensity you have to remember. In exams they can ask you like what is the intensity of drizzle. This you have to remember. Then we have glaze. Okay, I told you about glaze also. Then we discussed about how to measure precipitation. We have discussed different kind of rain gauges. We have certain recording and non-recording rain gauges. I hope you remember it. Then in non-recording rain gauge, which was the important one? The standard non-recording rain gauge of India. What was that? Kindly comment everyone. Yes, perfect. The standard non-recording rain gauge of India was, yes, it is Simon rain gauge. Yes, we have discussed this. Every day we have to measure the rainfall at 8:30 am daily, the diameter of which is 5 inches, or simply we can say 12.7 centimeters or 127 mm. This we already discussed. No object should be nearer. Where is that slide? Wait a second, one slide is missing from here. Okay, one slide is gone, no issues. We have discussed that the height of rain gauge, Simon rain gauge is 30 centimeter. I hope you remember it. Everyone kindly comment. Try to comment, try to participate. I am unable to see all of your, I'm unable to see the comments. Everyone try to comment. What is the, yes, what is the height of Simon rain gauge? 30 centimeter. Diameter you have to remember. Then we have a masonry block 60 by 60 by 60 centimeter cube we have, in which we fix it, Then we have a fencing of 5.5 by 5 meters. Okay, 5.5 by 5.5 meter of fencing, so that no animal gets inside and destroy this instrument. Okay, it should be safe, that we have understood. And it should be placed in an open area, that we have also discussed. It should not be near the tree or under the tree or near some building. It should be in open area, yes or no, at a sufficient height, not much height, or you can say not very low height. It should be placed at a sufficient height. Then we have discussed recording rain gauges, and in recording we have discussed tipping bucket. Everyone kindly comment, like tipping bucket gives you which kind of graph. Everyone try to comment. Yes, try to comment everyone. Tipping bucket gives you which kind of graph? See, I will make sure that everything is fully clear to you in the class itself. Yes, it gives you hytograph, intensity versus time graph. Then we have discussed weighing bucket, which gives you mass curve. Okay, here you can see that as the rainfall will continue, this weight of the bucket will increase and spring will get compressed, because of which will you will see that pen will start moving. And because of the motion of that pen, uh, on that chart you will see, that a graph is continuously plotted. Similar kind of you can say similar kind of mechanism is there to measure in natural siphon, which is the standard measuring rain gauge of India. This is important. They can ask you, like, which is the standard measuring rain gauge of India? What you will tell? Standard measuring range of India is none other than natural siphon type. Okay, so this you have to remember. This is very, very important. Okay, then we have discussed about rain gauge network. Can you tell me which country is having the highest rain gauge density? Rain gauge density is nothing but simply you can say how many number of rain gauges are there in a given catchment area. If number of rain gauges are more, then obviously we will have less error. Yes or no? More rain gauges means less error, higher accuracy we will have. Simple. Okay, so rain gauge density should be more if we want to accurately predict our data. Yes or no? Rainfall data. Then according to code, at least 10% stations should be recording type, and in plain area at least one station should be there in 520 square kilometers. Then in a region of average elevation or simply in plateau region, at least one station should be there in 260 to 390 kilometers square. Then in hilly areas with heavy rainfall, at least one station should be there in 130 square kilometer, that you have to remember. And density wise, you all know that plain areas should have less number of rainfalls and hilly areas should have more number of rainfalls. Why? Hilly areas should have more number of rainfalls. Why? Rain gauges, sorry. Why more number of rain gauges should be there in hilly area? Because it receives more rainfall. Okay, that I have already told you. I hope you remember it. Kindly comment once. I am unable to see your comments. Okay, kindly comment, like which will have the highest which area, plain area, plateau area, or hill area, which will have the highest rain gauge density. Can you comment? Can you comment down? Kindly comment in the comment section. Okay, after this we have to start today we have to discuss two basic topics. First is preparation of rain data. Okay, first today we have to discuss about how to prepare rain data. Okay, we will discuss about this preparation of rainfall data, and then we will discuss estimation of missing data. So I hope it will be very, very clear to you all. So before beginning, let us complete the topic which we have left yesterday. Okay, so first I will complete the topic which we have left yesterday. Today's the very first topic will be adequacy of rain gauge stations. Okay, adequacy means what? Can you tell me the meaning of adequacy? Everyone kindly comment. No dear, no circular area for, wait a second, one problem is there. Okay, sir, we will take circular area for engage. No, it is not the case. Yes. Now, so we have to study this topic, adequacy of rain gauge station. See, adequacy means sufficiency. Okay, how many number of rain gauges should be there in catchment areas so that our error in precipitation data is less than an acceptable value? So how to evaluate it? For that we have certain number of steps. So we will learn that steps and then we'll solve a question so that everything is fully clear to us. So exactly as to exactly how to find the optimal number of rain gauges so that error is, you can say, limited, that we have to discuss. Okay, so try to imagine in your catchment area, I will clear the concept here, listen very carefully. Let us imagine that in a catchment area we have certain number of rain gauges. Okay, just imagine, let us say 5. Okay, we have 5 rain gauges installed in our huge catchment area. One boy has asked here that, sir, standard minimum rain gauges between two rain gauges. See, there is nothing mentioned as such. Okay, I will let you know where to place it, don't worry. And one more doubt is there, sir, will we take circular area for rain gauge? No, rain gauge is placed in any area. Okay, rain gauge is placed here. What is the meaning of circular area here? Catchment area is never circular. Okay, catchment area is never circular. The entire catchment area can be of any shape. It is, you all know, it is roughly circular, or you can say it can be of any shape. It is having not a no perfect shape is there for catchment area. And we have installed rain gauges at arbitrary locations. There is no you can say point in saying like what is the distance. Yes, obviously we will not try to see. It will be better if you are placing rain gauges near to each other, because if you will do so, then rain gauge density will be high. If density is high, the error will be less. If density is high, then error will be less. More accurate data you will have. And if you are placing it farther apart, if you are keeping the distance between two rain gauges farther, then obviously error will be more. In that case, accuracy will be less. Yes or no? So if you are packing rain gauges more closely, or you can say at a lower distance, then you need to understand we will have a more accurate data with less error. But that depends. See, now firstly the very first question is, sir, how many rain gauges we require? Ultimate question is that, sir, how many rain gauges we require? Okay, let us say if we want to have an error of not more than 10%, or we can simply say, sir, if we want to keep the error within 10%, then how many number of rain gauges we should use? Let us say we should use, let us take an example, let us say we should have 15 rain gauges. Sir, okay, now if you want to reduce the error even below 5%, then, sir, how many number of rain gauges? Sir, then the answer is like we should have 35 rain gauges. See, more the number of rain gauges, more the density. More the density means that they will be placed nearer to each other. Yes or no? I hope the concept is clear now. This is the doubt, Sushil. Yes or no? So the distance depends exactly on what is the error that you are interested in. Okay, if your error is less, if you want error to be less in quantity or more accurate data if you want, then obviously you will have more number of rain gauges installed in the area. And if more number of rain gauges are there, then they will be placed nearer to each other. Yes or no? So that is the case. And if you want error to be, let us say 20%, then obviously less rain gauges you require. So ultimately there is no rule as such, and simply you are saying you want, wait a second, yes sir, you are saying that you want number of rain gauges corresponding to a given error. If error is less, then number of rain gauges should be more. If we want to keep the error lesser, then we should have more number of rain gauges. That is the ultimate concept. Now, sir, tell me exactly, for a given catchment area, sir, exactly how many number of rain gauges we require for a given error? Is there any formula for it? Yes, there is a particular formula. And how we will determine it, that I am going to tell you in 5 steps. Okay, so the very first step is, yes, listen very carefully. So the very first step is, I will clear the entire concept here beautifully. The very first step is, you have certain number of stations. In our example, we have 5 rain gauges here. Okay, sir. Now the very first station is having a rainfall of P1. The second one is having a rainfall of P2. The third one is having a rainfall of P3. Similarly, the fourth one is having a rainfall of P4, and similarly, and so on and so forth, we have P5. Okay. The very first step is we will take mean. Okay. First step is that we will take mean precipitation. Okay. I hope you can take out the mean. Okay, mean is nothing, there is nothing tough in that. Okay, so mean precipitation, firstly we have to find. Okay sir, this is simple. Mean we can easily evaluate, okay, simply by summing up all the rain gauge values. Okay, whatever values they have, whatever values are coming, that we will simply sum up. Pi means P1, P2, I will vary from 1 to n. I will vary from 1 to n, divided by n, divided by n. Okay, simple. Then what we will do? See, this is mean precipitation. Then the second step is, we have to find standard deviation. Then the second step is that we have to find standard deviation. Okay, simple. Standard deviation is denoted by sigma. Okay, standard deviation is denoted by sigma, and in the subscript we have, n minus 1. In the subscript we have n minus 1. Okay, then we have under root. Okay, see, we have obtained mean, yes or no? Now we have to subtract all these values, p1, p2, p3, p4, p5, all the values separately from mean. Okay, we have to subtract them. We have to find a deviation of each and every value from mean. Okay sir, you are saying that we have to subtract mean from each and every value. First we have to do p1 minus pm, then p2 minus mean, p3 minus mean, like that. And all the deviations will be squared now. All the deviations will be squared. Okay, whatever will the difference between precipitations and mean, that will be squared up, and all these deviation square are now summed up. They will be summed up and divided by n minus 1. Don't worry, I will also solve a question. I will also solve a numerical with the help of which you will be able to understand it beautifully. Okay, yes or no? So I hope till here everything is clear to you. Till here I hope everything is clear to you. So this is the second step. Now what is the third step, sir? In the third step, we need to find coefficient of variation. Okay, coefficient of variation is a term. It's very important. Okay, coefficient of variation is used to basically compare two rainfall data. Okay, so CV, this is also denoted by CV. So coefficient of variation is nothing but CV. I hope this is very clear to you all. Okay, CV is denoted by sigma. Sigma you have already found out, standard deviation upon mean. Okay, standard deviation upon mean is nothing but CV. And if we want to find CV in percentage, then we will multiply it by 100. And if we want to find it in fraction, then obviously we will not multiply it by 100. Yes or no? This is very simple logic. Okay, so CV is nothing but sigma upon mean. Standard deviation C, step number 2 upon 1. Okay, whatever values we have obtained, we will find the coefficient of variation in percentage. Okay, that's why we have multiplied by 100. Now, the fourth step, which is the most important one, here we are interested in finding, listen very carefully here, the heading is sufficient number of rain gauges. Sir, how many rain gauges we require? Sir, how many rain gauges we require in order to minimize our error to 10%, or let us say 5%, like that question will be given. In question they will give you the error. In question they will give you error. So for given error, what is the number of rain gauges that we require? So that will be found out with the help of this fourth point. Fourth point is none other than, what is the optimum number of rain gauges? What is the optimum number of rain gauges for given error? What is the optimum number of rain gauges for given error? Yes or no? For given error epsilon. Okay, this is the main formula, and this will be denoted by capital N. Capital N is the main, you can say, formula, which is none other than CV upon error whole square, because in questions error will be given to you. Okay, error will be given to you, and that you have to put here in percentage. Why? Because CV is also in percentage. See, if CV is in percentage, then error should also be in percentage. CV means coefficient of variation. If it is in percentage, let us say 30%, then if error is 5%, you will put both in percentage, or you can put both of these values in fraction. Remember that they should be in same proportion. Okay, this you have to remember. So from this formula you can see what I can conclude from this formula, sir, that what if error is less? Tell me, if we want to minimize our error, if we want to minimize the error in rainfall data, then tell me the number of rain gauges will be less or more. Can you tell me? Can you tell me? If I want to minimize our error, if we want to minimize the error, the number of rain gauges will be, can you tell me? Kindly comment everyone. If we want to minimize our error, if we want to reduce the error, then obviously the number of rain gauges will be more. See, if we will reduce the error, then number of rain gauges will be more. No, it will be, listen very carefully, it should not be more, it should be very, very more. Why? Because here we have a square. Okay, if you will reduce the error by half, then number of rain gauges required will be 4 times more, because half square will be 4 times, because we have a square here. So if we want to reduce the error, you can say if you want to reduce the error by half times, then number of rain gauges which are required will be in 4 times more. Okay, that will be 4 times more. Yes or no? I hope this is clear to you. Simple logic. Yes or no? Simple. Okay, sir. Understood. Now, sir, please let us make solve one question so that we are able to understand the entire concept. At last, they will ask you like find the additional number of rain gauges. At last, they will ask you find the additional number of rain gauges. Okay. Find the additional number of rain gauges, and that additional number of rain gauges will be what? Let us say that is M, or we can say, yes, we can call them M. See, this is the required one, and already which you have here is small n. So capital N minus small n will give you how many more rain gauges you should install so that error is within the limits. Okay. So I hope understood clearly. Perfect. Now we'll try to solve one question. Everyone please take out your calculators and solve this question. Okay. See, remember these 5 steps. We'll not come back to the slide. We will in the question we'll perform these operations, and at last we'll find what are the optimum number of rain gauges required for a given error, and what is the additional number of rain gauges that is required here. Okay, are you ready? Okay, sir. So mean standard deviation CV, then n. See, mean standard deviation, remember, then sigma upon mean is CV. Memorize this slide, try to remember this slide, then we'll proceed further, and everyone take out your calculators. Okay. So I hope this is clear to you. We'll move further now. Okay, so wait a second, we have a question here. Yes, this is the question. See what this question is saying. Read it very carefully. What this question is saying. This question is saying the average normal rainfall of 5 rain gauges in the base stations are 89, 54, 45, 41 and 55 centimeters. It simply means that in our catchment area, how many rain gauges we have already? Sir, it is very simple. In our catchment area, we have 5 rain gauges placed arbitrarily. Okay, 5 rain gauges are there and we have placed it arbitrarily. Okay, all rain gauges have received some amount of rainfall. Then this question is saying if the error in the estimation of rainfall should not exceed 10%. That means our error should be less than 10%. Okay, it is saying it should not exceed 10%, which means that it should not be more than 10% or it should be less than 10%. This is the case. So how many additional rain gauges are required? How many additional rain gauges are required here? So obviously, sir, we will easily solve it. We have 5 simple steps that you have already told us. Okay, so in the very first step, sir, we have to simply find the mean precipitation, okay, of the working rain gauges which are already installed there. Okay, how many number of working stations we already have is 5. Simple. Okay, sir. So tell me what is the mean. Tell me what mean we are getting here. So simply find the mean. 89, 40, 54. Let me solve it. You also solve it. You will tell me the answer. Whatever you will tell, I will put it here. Okay, everyone try to find the mean. We have 89, then we have 54. Okay, sir, then we have 54, then we have 45, then we have 41, then we have 55. Okay, so this is our mean. This is our mean divided by 5. Okay, simply mean you all know. So how much we are getting here? Can you tell me how much we are getting here? Everyone try kindly comment. I will also solve in my calculators. Okay, so how much we are getting here? Okay, 56.8. Great, Sushil and Kiran. Okay, very good. You are getting it as 56.8. Perfect. Obviously, it will be in centimeters. Okay, we are giving the units in centimeter. Okay, sir, understood. I hope this is very clear to you. Second step. Sir, second step is what? In the second step, sir, we have to simply find sigma, standard deviation. Okay, we have to simply find sigma n minus 1. Understood, sir. Sir, how we will solve this? See, firstly, you have to do what? Firstly, you have to subtract all the values from mean. Subtract all the values from mean and square it. And then sum it up, divide by n minus 1. Okay. So first what I will do? 89 minus 56.8, square it. Then 54 minus mean. 54 minus mean, again square it. Then 45 minus mean. See, you need to understand one thing here. Sir, why we are squaring? See, we are squaring because we are only interested in deviation part. No matter if deviation is positive or negative, value can be going ahead of mean and value can be going behind mean. Okay, it can go in both directions. But if it is going in positive direction and if it is going in negative direction, we are only interested in the magnitude, the positive part only. That's why we are squaring. Because be it negative value, you can see that this value is behind mean, it will be negative, and this value is ahead mean, so this will be positive. No matter what, sir, when you will square it, sir, when you will square it, you will get the positive deviation. Okay, that's why we are squaring it here. And at last, I will put the root also. First you square it and at last you put a root also. Okay, so that will balance it. So first 89, 54, 45, then we have 41. Then 41 minus mean value, square it. Then 55 minus mean value, then 55 minus mean value, square it. Okay, understood, sir. Divided by n minus 1, divided by n minus 1, divided by n minus 1. What is n? N is 5. So how much we are getting? Tell me how much we are getting. Solve this value. What you are getting, kindly tell. Solve it everyone. Try to solve it. Okay, we have to find it. We have to, some way or the other, we have to find it. Tell me how much we are getting here. Perfect, Kiran. You are giving the absolutely correct answer, 18.95. Great. We are getting it as 18.95 centimeters. See, unit you need to understand. Unit you have to understand. See, firstly we have squared it and then we have under root again. Okay, so centimeter square is, see, first we have done centimeter square, then again we have done under root. So obviously unit will be in centimeter. Okay, now we have to go to third step. Yes or no? So third step is nothing but CV. Okay, sir, now we have to find coefficient of variation. Sir, what was the formula? What was the formula for coefficient of variation? Sir, it was very simple. Sir, coefficient of variation was simply, you can say, sigma upon mean, nothing else, into 100. So can you find this value? How much we are getting here? Can you tell me? Very good, Kiran, you are giving the absolutely correct answer. I hope everything is clear to other students also. So coefficient of variation is nothing but, okay, we can simply write CV also here. We can write CV here also. Sigma upon mean into 100. So sigma we are getting here as 18.95. Sigma we are getting here as 18.95 divided by 56.8, divided by 56.8 into 100. So how much we are getting here? 33.36. Okay, great. We are getting it as 33.36%. Okay, great. Now you can say basically the last step. Now we have arrived to the last step. Okay, now how many rain gauges we require? How many rain gauges we require? What is the optimum number of rain gauges? Optimum number of rain gauges for error to be less than 10%. Tell me what is the optimum number of rain gauges? What is the optimum number of ranges required to minimize our error or put it below 10%? Put the values here. Put the values here. Error, see, you can see in the question, the error which is given to us is 10%. Okay. See, both should be in percentage. So CV which we are getting here is 33.C6% and divided by 10, square it. How much we are getting? How much we are getting? Yes, 11.13. Perfect. Perfect, Sushil. You are getting it as 11.13. Great. So can you tell me what will be the answer? Can you tell me what will be the answer here? They are saying how many additional rain gauges we require. Can you tell me how many more rain gauges we require in order to minimize our error below 10%? Can you tell me? How many more number of rain gauges we should install in our catchment area? Can you tell me that? How many more rain gauges require? We already have 5 here. Okay, we already have 5 and you can simply say that 11.13 is approximately equal to 12. So we need 7 more stations. Yes, you are right. But we need to understand one point here. Okay, you are absolutely correct here. You are absolutely correct here. You are saying that we should have 12 number of rain gauges total so that error is below 10%. But one thing you need to understand. See, if we have exactly 11.13 rain gauges, then error will be exactly equal to 10%. Yes or no? Do you agree with this? Sir, initially when we have, sir, 5 number of rain gauges, then error was more than 10% or less than 10%? Initially when we have 5 rain gauges, then error was more than 10% or less than 10%. Can you tell this? Can you tell this? Kindly comment. Initially when we have only 5 rain gauges, then obviously error was, tell me, then error was obviously, sir, more. Then obviously error was beyond 10%. Yes or no? But now when I will provide exactly 12 rain gauges, then error will be less than, see, at 11.13 we have 10% error. But if I will increase the number of rain gauges to 12, then obviously error will go down. And this is the exact requirement of our question, because our question is saying that error in the estimation of rainfall should not be more than, should not exceed 10%. It should not exceed. So this is the correct case. Okay, we cannot take this. Yes or no? And also you cannot apply, or you can say you cannot install the rain gauges in fraction, half or full, like that. Okay, you cannot install half rain gauges. So obviously we need 12 rain gauges. So this is our correct case. Now, sir, what is the additional number of rain gauges, sir? Obviously the answer is 7 now. Okay, so additional number of rain gauges which we need to install is simply what? 12 minus 7. Oh, sorry, 12 minus 5. Because initially we have 5 and now we want 12, so that error is less than 10%. So this will be 7. So I hope it is very, very clear to you. So I hope these type of questions you can easily solve in your examinations. Okay. I hope this is very, very clear to you. One thing we need to understand here. Is this thing clear? Everyone kindly comment yes, then we'll proceed further. See, one more thing we need to understand from here. We have to understand the significance of CV. What is CV? Okay, what is CV? We have to understand the significance of coefficient of variation here. Okay. Okay, dear. Perfect. Now listen very carefully. See, what is the significance of CV here? See, coefficient of variation has certain significance. Coefficient of variation has certain significance that you need to understand. It basically, see, basically it gives you exactly, it tells you about how your rainfall data is varying. Okay, are all the rainfall data, or you can say are all the rain gauge values same or different? See, let us take example. Let us take an example with the help of which you will be able to understand this concept very easily. Okay, let us imagine we have 2 batsmen. Okay, we have 2 batsmen. Tell me who's your favorite batsman. Can you name one? Okay, my favorite batsman is the one who is husband of Anushka Sharma. Okay, can you name him? Let us compare, you can say let us compare data of 2 batsmen. Similarly, we'll compare data of 2 rainfall. Okay, do you have any favorite batsman? Okay, Kiran is saying Virat. Okay, so we will take example of Virat Kohli and we will take example of Surya Kumar. Okay, these days he is also shining. So we are taking example of Virat Kohli and Surya Kumar. I hope you all know them. Okay, you are taking MSD. See, MSD is at next level. Okay, we will not compare them, but so let us take, they are playing 3 innings. Okay, both of them are playing 3 innings, and Virat Kohli is making in those 3 innings. In at one time he has secured 49, then 50, and then 51. So if you will take out the average, can you tell me what is the average here? Mean of Virat Kohli in these 3 matches will be 50. Okay, this will be mean. Yes or no? Mean will be 50. But you can see that all the runs which he has scored are almost more or less same. Yes or no? He's a consistent batsman. Yes or no? Then we'll talk of Surya Kumar. Okay, 1 month left for JE. Which JE Yasin, can you tell me? Yes, average is 50. Can you tell me which type of JE you are asking? I will give you the tips, don't worry. Then Surya Kumar, see, he is a kind of moody batsman. He doesn't, you know, he is least bothered no matter if he's playing at 50 or 100, no matter what, he hits, okay, every time. You all know this. So he scored 0. Then again in the next match he scored 0. And suddenly he scores 150. Okay, now tell me what is the mean of Surya Kumar. Okay, Yasin is saying JK SSB JE. Okay, Jharkhand one. Okay, Jharkhand one you are talking of. So here again mean is what? Sir, here again mean is 50. So what you can infer from here? See, if you are you can say a businessman, and if you are getting a chance to buy players for your IPL team, tell me who will you buy? Can you tell me which player will you buy? Okay, JK is Jammu Kashmir one. Yes. One boy has asked me. Yes, one boy has asked me like many a times about Jammu Kashmir JE. Obviously, yes, you all know that we will try to buy Virat Kohli. Why? Because he's more consistent. See, mean is same for both of them, but still you are inclined towards Virat Kohli. Why? Because he's more consistent. If we talk of deviation, see, deviation means what? Difference from mean. See, here difference from mean is -1. Here difference from mean is 0. Here difference from mean is 1. But if you will see difference from mean here, you will see that there is a huge difference in all the datas. So he is not a quality batsman. Yes or no? You will see that deviation here is less and here deviation is high. See, so we are saying here, so for if we want to compare CV, see, mean, if mean is same, then if sigma, see, if you have same mean for both the batsmen, if you have same mean, then coefficient of variation or deviation, standard deviation are proportional to each other. If variation is more, if deviation is more, then variation is also more. Yes or no? So we can say for those two batsmen that CV, coefficient of variation, is less here, deviation is less here, and here we have more variation. Obviously, quality control is better for this batsman. Yes or no? Because he is consistent and every time you will get the same result. So you can rely on it more. Yes or no? In a similar fashion, if we want to compare two rainfall datas, okay, then we will find coefficient of variation. This is the ultimate significance. Okay. So I'm writing the very basic point here that CV is used to compare, or coefficient of variation is used to compare two rainfall datas. See, one thing you should understand that in India, rainfall is not a constant phenomenon. Okay. See, rainfall is very variable. Let me give you a very brilliant idea here. Okay, listen to the fact. See, you know that rainfall happens, basically you will see that the rainfall which happens in entire year, 50% of the rainfall, okay, 50% of the rainfall which happens in a year falls, or you can say happens, only in 15 days. You have 365 days in entire year. Only within 15 days most of the rainfall happens. Okay, only within 50 days 50% or more than 50% of the rainfall happens in a certain area, and in the remaining 350 days we have the remaining 50% rainfall. So rainfall is a very variable quantity. Sometimes it happens in more quantity, it will happen daily, and most of the time of the year you will see that no rain is happening. So it's a variable kind of phenomena. So ultimately that variable thing, that variation is basically measured by this coefficient of variation. If we talk of entire India, this CV for entire Indian average, okay, if we talk of entire Indian subcontinent, this the average value of CV is somewhere around 30. At some places it is less, as less as 5, and at some places it is as high as 50, but average value is somewhere around 30. Okay, but coefficient of variation is there. See, if rainfall is not varying, if it is happening daily on daily basis, or you can say it is happening daily for a certain magnitude, let us say we are having in a certain area we are experiencing 5 centimeter rainfall daily, every day 5 centimeter rainfall, then I will say that rainfall is, you can say it is perfect kind of rainfall, no variation is there. Okay, but if it is varying, at some day nothing is happening, at some day nothing is happening, but again someday that immense kind of flood is happening, so that you need to understand that if it will vary, then obviously this coefficient of variation thing will be very very high. Okay, so you have to understand that in India, you have to understand one thing, that in India we have variable conditions. Okay, we don't have any consistent conditions here. In India you will see that variability is there. Okay, so it is basically used to compare two rainfall data, like which is more which is having more variation and which is having less variation, that you need to understand. Okay, one more thing, Indian rainfall is variable. Indian rainfall is a variable quantity. Okay, it is not a fixed thing. Indian rainfall is variable. Is variable. Okay, so basically coefficient of variation tells you so as to how much variation in a rainfall is there. Okay, so ultimately this is your coefficient of variation. Coefficient of variation is an important term. Significance is basically is to compare two rainfall data or tell you exactly how much variable a rainfall is in a certain area. Okay, it signifies how much variable a rainfall is, how much variable rainfall is in a certain area. Okay, so this is your coefficient of variation. So I hope this is very very clear to you. Now we'll move on to the next topic. So I hope with the help of this explanation you are able to understand the entire concept of adequacy of rain gauge stations. Okay, I hope this is very very clear to you. You will easily compare two rainfall data. So you can easily tell you which rainfall is more variable and which is less variable. See, one more point is there. See, at those places where we have more rainfall, listen very carefully. At those places where we have more rainfall, obviously there daily you will see some rainfall is there, so variation is less as compared to those places where we have very scarce or less rainfall. Okay, imagine we have a desert area and we have a hilly area. In hilly areas we have more rainfall, yes or no? In hilly areas we have more rainfall, but in desert areas, sir, we have very mild or you can say rare rainfall, yes or no? Rainfall is very very rare in desert areas, you all know this. So variability in desert area will be very very high. Okay, why? Because 0 0 0 and immediately you will see 10, like that. So variability is too much in desert area, but in hilly areas daily rainfall is there, so obviously you will not see much variation. So one more point let us write here, that uh, variability, if we talk of variability, sir, you are very much familiar with the thing that Indian terrain is variable. Okay, in some places you will see desert condition in there, some places you will see that ice is happening. Okay, it's a frozen frost place. In some places, sir, you will see that we have it is receiving very very heavy rainfall. So sir, it is varying. Indian terrain is very very variable. But if we talk of variability, sir, desert areas, or you can say the places which are having low rainfall. Okay, desert areas or places which are experiencing less rainfall or scarce rainfall, those are more variable. Okay, in those areas we will have more variability. This question can be framed in your examination. Okay. So Sushil is asking one question here: is runoff depend on coefficient of variation? Obviously, it will depend. See, coefficient of variation gives you rainfall, and rainfall is responsible for runoff. Okay, if rainfall is disturbed, then obviously runoff is also disturbed. Yes or no? So what I was saying here is, see, runoff thing I will tell you later. So there you will understand the entire concept. No need to worry about that. Okay, let us come back to desert. We have to compare these areas. So one is your desert place which is having less rainfall, scarce rainfall, their variability will be more. And if we talk of coastal areas or hilly areas, in places where we have heavy rainfall or high rainfall or more frequent rainfall, okay, opposite of less will be heavy here. Okay, heavy will be more suited here. So at places where we have heavy rainfall, their variability will be less. So this you also remember. Okay, so at places of more rainfall we have lesser variability, and at places of least rainfall, or you can say where rainfall is not happening, where we can see drought conditions are there, there we will have more variability. Fluctuations will be more in that places. Yes or no? Okay, so I hope this thing is very, very clear to you, and I hope with the help of this example you are able to solve the question which is based on your sufficient number of rain gauges. Okay, so this is the ultimate thing. Now we'll move on to the next topic, which is preparation of rainfall data. So is this thing clear till here? Everything is clear till here? Everyone kindly comment yes, then we'll proceed further. Everyone kindly comment yes, then we'll proceed with our next topic. Okay, you are asking about JEE. See, Yasin, you have asked about Jammu Kashmir JEE examination. So if I was at your place, okay, if I was at your place, then what I would have done, I would have solved as many questions as possible in the last days. Let us take an example of 200 to 300 or 400 questions on a daily basis by sitting in a library or studying on a table chair at a perfect position. Okay, so see, the place should be fixed, and daily on a daily basis you have to solve as many questions as possible in a limitless way. Okay, from basic books, you all know that Gupta book is there. Okay, then we have ESC previous year questions, we have to solve that. Then we have firstly we have to cover the entire SSC previous year. Okay, and all the questions which have already been asked in other state exams, which are basically given in a youth book. Okay, so all these books are very, very important when it comes to your other state examinations, so that you have to solve rigorously on a daily basis. This is the ultimate tip. Okay, and secondly you have to revise the subjects which you have covered. Okay, I hope you must have prepared short notes or something, or if it is not there, then you must have some good handbooks. Gatopedia is there, in which all the concepts are given, okay, in a short way. So you can read out those pages and simply you will get the revision. Okay, so revision and question practicing is the ultimate thing which you have to do in the last days. Okay, so I hope with the help of this everything is fully clear to you. Okay, nothing else I know. Okay, if I was at your place, I would have done the same thing. Okay, now, so now we are interested in the preparation of rainfall data. See, we have measured rainfall now. Till now, we have measured the rainfall. Yes or no? Sir, we have measured it with the help of rain gauge, ombrometer, pluviometer, hytometer, all are the same. We have studied recording rain gauges. We have studied non-recording rain gauges. Sir, we have simply measured the rainfall. Now we have data. In entire catchment area, let us say we have 10 rain gauges, 9 are non-recording type, 1 is recording type. Sir, you have already told this thing that some rain gauges should be recording, so that we are having the temporal variation or the timely variation of rainfall. We should have certain rain gauges as recording type. Yes or no? We should have certain rain gauges as recording type. Okay, sir, this is also correct. Now, sir, if we have some ranges, see now, see, we have these rain gauges installed in entire catchment area, and obviously they will measure rainfall daily basis. Every day at 8 a.m. you will collect the data and you will have certain amount of rainfall. Let us say 5 mm, 10 mm, like that. Yes or no? You will have rainfall data 5 mm, 10 mm, 15 mm, like that. So what we have to do of that? Okay, what we should do with that, that I'm going to tell you. So firstly, you need to understand that our data should be continuous and consistent. Okay, sir, what is the meaning of continuous and consistent? See, continuity means what? First, you have to listen very carefully. Continuity means what? Continuity means that if you have in a catchment area 10 stations, all those 10 stations should be perfectly working. All those 10 stations should be perfectly working. Let us take an example. Suppose that in a particular year, let us say 2020, in year 2020, only 9 stations are working and one rain gauge has failed. Maybe because of any reason, but let us assume that one station has failed completely. So what is there? That data is discontinuous. Why? Because all the 10 stations are not working. All the 10 stations are not working there, only 9 are working, and one has failed to operate in that particular year. So if one or two rain gauges are not working in a given year, then I will say that the data which I have received, is discontinuous. Yes or no? I hope this is very, very clear to you. So if some rain gauges are not working properly, then I will say that the rainfall data is discontinuous. Yes or no? This is the meaning of discontinuity. And if all the rain gauges are working properly and we are collecting the data properly in a given year, in 2020, in 2021, in 2022, all the rain gauges are working properly, we are getting the yearly data properly, then I will say that data is continuous. I hope this is very, very clear to you. Which means that sometimes it can happen that some stations are not working. We call that as missing data. Okay, missing data means we have to find the missing data. If some stations are not working due to some reason, okay, if some stations are not working because of some reason, then we have to find that value so that our data becomes continuous. I hope this continuity thing is very, very clear to you. Okay, great, dear. Give your best. See, the ultimate thing is that you have to give your best, then you will nail it. Okay, great, dear. Okay, so what I'm saying here is the data should be continuous. Then we have consistency thing. Now what is consistency? If a certain rain gauge, or simply we can say it as a station, is you can say is experiencing a drastic change in its pattern. If it is experiencing a drastic change, see what is the change here. Let us suppose in every year, let us say in some year it is experiencing a rainfall of, let us say, 105 mm. In next year 92, in next year again 104, next year 99, like that. So it is receiving a rainfall on a yearly basis like this. But suddenly what happened that we are experiencing a drastic change. Sir, suddenly we are seeing that rainfall has increased to 210, 205, like that. So after this year, sir, you can see that, or you can say before this year, drastic change in the pattern has been seen. Then I will say that that station has gone mad. That rain gauge has gone mad because of certain factors, because of certain reasons. You can say that my data is not consistent or inconsistent. That data has become inconsistent. So we have to do something. In order to make it consistent. So consistency means what? Data is following a similar pattern. Data is following a particular trend. Again and again, it is repeating its value. More or less, all the values are same. But if we have a certain, you can say, drastic change. Okay, if it is experiencing a drastic change, the value is going very high or very low because of some reasons. Okay, then I will say, sir, that my data is inconsistent. So I have to remove that inconsistency. So ultimately, sir, you are giving me 2 points, that my data should be continuous, which means no data should be missing. Okay, we should have all the stations working, and every year we are getting the proper data. Stations should be continuous, data should be continuous. And the next thing is that all the stations are giving you similar type of values every year. Okay, all the stations are giving you similar type of values every year. It should not be the case that after a particular year we are experiencing a drastic change. That should not be the case. So my data should be consistent also. It should not be inconsistent. A drastic change should not be there. Okay, that is the case. So my data should be, tell me, my data should be what? Everyone kindly comment. Yes, Yasin, you are right. But one thing you have to remember in life, very important principle of life, that the things which are not in our control, we should leave it. The things at which we cannot work, okay, which are not in our hands, we should not think about it. Okay, we should only think or pay attention to only those things which are in our control and we can act upon it. Okay, so don't worry about it. The external situations which are not in our control, we should leave it as early as possible so as to keep our us calm. Yes or no? So this is the ultimate tip which I have given to you. Okay, remember this. This will help you a lot. Okay, it has helped me also many a times. That's why I'm sharing it. Because of your comment, I have told you this. Okay. Now the next thing here we have is normal precipitation. Now what is normal precipitation? See, normal precipitation means, try to imagine one thing. See, firstly we have to understand about average annual rainfall. So then I will tell you normal precipitation. Now first tell me what is the meaning of annual here. Annual means yearly. You all know this. Annual means yearly. I have given you the example of Simon rain gauge. You all know what Simon rain gauge is. Everyone knows this. Okay. Sir, Simon rain gauge, you have told us that every day at 8 a.m. or 8:30 a.m. we go and measure the rainfall. The rainfall which we measure on a daily basis at 8:30 a.m. is called as daily rainfall. Understood, sir? Now let us take an example. Let us say on 1st January we have 5 m rainfall. See, listen very carefully. This is very important. Average annual rainfall concept. Okay. Every day we measure rainfall. See, this concept is very, very important. Average annual rainfall and normal precipitation. So listen very carefully. Daily rainfall we measure. Now if we on 1st January, imagine we are measuring the rainfall as 5 mm. On 2nd January, let us say we have 4 mm. On 3rd January, let us say no rainfall is there, like this. So if you collect daily rainfall and sum it up for entire year, then we will have yearly rainfall. Then we will have annual rainfall. Okay, annual rainfall is what? For entire year. So let us say for 2020 we have entire rainfall as 125 centimeter. For 2019, let us say we have entire year rainfall as 112 centimeter, like that. So we will take how many years? We will take 35 years. We will take 35 year data. Tell me how much data we will take? How many yearly rainfalls? How many L1 rainfalls we will take? Sir, we will take 35 data. Okay, we will take 35 year data and we'll take out average. Okay, so we will have 35 years. Okay, obviously last 35 years we'll take. Last 35 years. The latest 35 years we want. Okay, we want latest 35 years. I hope this is very, very clear to you. So we'll take average of that. We will take average. See, we will sum it up and divide by 35. That will be the annual average. That will be the annual average. So this is known as average annual rainfall. I hope this thing is very, very clear to you. How we measure annual rainfall? Annual rainfall is measured simply by adding up the daily rainfalls. You have the daily data, add it for all the days of entire year, all the 365 days. Okay, sum it up for all the 365 days and you will get the annual rainfall. Now take 35 annual rainfalls and take its average. That is your average annual rainfall. So I hope this thing is very, very clear to you, how to find average annual rainfall and how many years for how. See, generally it is assumed that after 35 years climate repeats its pattern. That's why we take cycle of 35 years. Okay, that is also the case, but that is not so important. Okay, sir, understood. Average annual rainfall is very, very clear to us, and you should appreciate the fact that average annual rainfall in India is somewhere around 119 centimeter. In some books it is saying 117, at some places it is saying 118, at some places they have rounded off to 120. So 117 to 120 is the range, but 119 is the value which you can remember. 118, 119, like that. Okay, this you have to remember, the average annual rainfall of entire Indian subcontinent. I hope this is very, very clear to you. Then we have normal precipitation. Now sir, what is normal precipitation? Tell me. See, normal precipitation is basically, normal precipitation is again the average for 30 years. Normal precipitation is again the average of 30 years. Sir, but what is the difference? See here, very big difference is, one big difference is there, that in this we only take average of annual rainfall, but here we take average for 30 years, but for a particular, listen very carefully, for any particular date, for any particular date, month, for any particular date, month, or a year. Okay, you have to understand this. See, let us take an example of any particular date. Let us take an example of any particular date. Today, what date is today? Today is 1st March, I guess. Yes or no? Today is 1st March. So 1st March 2023. This is 2023. Then 1st March 2022. Then again 1st March 2021. Like this, you have to take data for 30 year for a particular date. For a particular date, which is 1st March that we have taken. Okay, imagine at 1st March no rainfall has happened. In 2022, let us say 5 mm of rainfall has happened, like this. Okay, we have to collect rainfall data for a particular date. We have to collect a rainfall data for a particular date for the last 30 years. So that will be called as normal precipitation of 1st March. Normal precipitation of 1st March means that we are taking average for last 30 years. Similarly, if we are considering a particular month instead of date, if we are considering a particular month, such as, let us take an example of June month. Okay, so let us say June 2023 is experiencing this much rainfall, June 2022 is experiencing this much rainfall, 2021 is experiencing this much rainfall, and we are taking average of last 30 years. And if we are taking average of last 30 years, then I will say that that will be your then that will be your what? Then that will be your normal precipitation for month of June. That will be normal precipitation for month of June. Yes or no? And if you are taking average of entire year for last 30 years, if you are taking yearly averages for last 30 years and you are taking the average, that will be normal precipitation for the particular year. Okay, I hope this is very, very clear to you. So we can take what, sir? We can take average of particular date, we can take average for last 30 years for a particular month, and also we can take average for last 30 years for yearly rainfall. Okay, that average we can also take. So all the options we have. So basically in normal precipitation, sir, we can go and take average for particular date, month, or year. That is the case. Okay, basically it gives you the trend. Ultimately it gives you the trend for a given station. That is your normal precipitation. I hope this is very clear to you. So this normal precipitation thing and average annual rainfall thing, I hope is very, very clear to you. See, all the Indian forecast of rainfalls are basically prepared at Indian Meteorological Department, which is located in at New Delhi. Okay, and the water year in India starts from the first day of October. It is not the case. Generally, it happens on the first day of June. Okay, first day of June. See, this October thing is not in India. It is, you can say, in America. Okay, in India, the first day of June is the beginning of water year, and the last day of, see, from 1st June to 31st May. Okay, from 1st June to 31st May is your water year. See, you have a financial year. I hope you all know what financial year is. Okay, financial year basically starts from 1st April and finishes on 31st March. You know this? Do you know this? This is financial year. Okay, similarly, your water year is starting from 1st June and ending on 31st May. This you have to remember. Okay, this is water year. This is a different thing. And you all know what average annual rainfall of India is. So I hope this is very, very clear to you. I hope this thing is very, very clear to you. So this is preparation of your data. This is preparation of your data. Okay, and our data should be continuous and consistent. Okay, we have to discuss now estimation of missing data. That I think we should start tomorrow. Okay, from tomorrow onwards we'll start the estimation of missing data, because it's a long topic. It will take more than half an hour, so I will start it tomorrow only. But yes, you have to remember one thing, that in estimation of missing data we have some methods. We have arithmetic mean method, we have normal ratio method. We have to discuss them. Okay, those are basically methods in which, see, whenever I told you when we estimate missing data, sir, we estimate missing data only when whenever there is a break in record. Okay, due to absence of observer, if observer is not there, or due to some other reasons, let us say we are unable to get the rain gauge reading in the particular year. Let us say that a rain gauge is recording rainfall every year. You can say every rainfall we have that data, but in some year, let us say in 2022 or 2020, we are having no data of that rain gauge, and it may be because of several reasons. Let us say observer has not taken the reading, and let us say that instrument has failed, or any reason. Okay, no matter whatsoever is the reason, but still data is missing. So we have to find it. Okay, there are many methods which we'll discuss in the next class. Okay, sir, which one gave more accurate data between these two? So which one gives, see, there the question is not of accuracy, but yes, if you talk of more accurate, then arithmetic mean and normal ratio method gives you the more accurate data. Okay, so we are ending here at today, and in the next class we'll discuss estimation of missing data. See, in the next class what we'll try, to make our data continuous and consistent. Both will be our concern. Okay, in the next class we'll try to make our data continuous means if any data is missing or if there is a break in record, we'll try to make it continuous tomorrow only. And secondly, if there is a drastic change in pattern, if any rain gauge station is showing a drastic change in a pattern, are you able to understand this? If my rain gauge station is showing a drastic change, okay, if rain gauge station is showing drastic change, then we have to make that data consistent. If it is inconsistent, then we have to make it consistent. From inconsistent we have to make it consistent. How we do it? We do it with the help of a technique known as double mask curve technique, that we will discuss tomorrow. Both these techniques will be discussed tomorrow, and also we'll tomorrow learn the methods of, okay, some methods of presenting data, that we have to discuss. After that we have average depth. Okay, some 2 to 3 classes will be required to finish your precipitation chapter. Okay, great. So we'll catch up tomorrow. One doubt is here, sir, please help, my exam is on 1st April, still SOM is pending, what study should I apply? Please help, sir. See, Adil, if it is, see, SOM is very important. If you have not covered SOM till now, that means your preparation is not up to the mark, first thing. But what you can do, that I will obviously guide you. See, you have to solve some important questions of important topics. See, as you know that in SOM we have properties of material as the very first topic, then we have shear force, bending moment, diagram 1. Okay, then we have transformation stresses. You have to at least cover some chapters, and that can be done within some days. In 10 days also you can cover as many topics as you want, but it depends on your seriousness. Okay, pick up a playlist on this channel only, which is giving you SOM. Okay, crash course we have covered. Just now gate has happened, and before that we have covered a crash course. Okay, so you can on gate IME C and XG channel you can cover SOM of Anirudh sir. There he has taught brilliantly, and study some chapters. After that, after getting the entire basic, you have to go to your question solving. Okay, so that will be more than sufficient. So give 5 days for SOM. In 5 days try to complete 5 chapters. First cover the basics, and the entire day solve as many questions as possible from this topic, and at least some command you will get. I'm telling you some chapters that you have to study. First is properties of material. Don't go into the depth, only cover the basic things. Then second one is your shear force and bending moment diagram. Then we have transformation of stresses 1, and then at last we have deflection. Deflection is very important. So you have to cover these 4 topics. Okay, SOM class is starting tomorrow. Then also that is good. Okay, then also that is good. You can cover from there also, no issues. But you have to cover the topic. Okay, so this is it from my side today. We'll catch up tomorrow, and we'll cover the estimation of missing data and inconsistency of record. Okay, so take care, stay blessed. Good night, everyone. Take care. We'll catch up tomorrow. Okay. Stay blessed.